So here is the energy worksheet that I have provided for you. I will be going over each question so that way you can check your answers. So number 1 says a cart is loaded with a brick and pulled a constant speed along an inclined plane to a height of a set seat top. If the mass of the loaded cart is 3 kilograms and the height is 0.45 meters, what is the potential energy of the loaded cart at the top? So we are trying to find potential energy. Again, potential energy is going to be mass times gravity times height. Gravity is going to always be 9.8 for us, so we need our mass, which they gave us right here, and then the height, which they give us here. So we're going to plug all those into the formula. The mass is 3 kilograms. Gravity is always 9.8. And the height is that 0.45 meters. You're going to multiply all three of those numbers together and you'll get 13.2, and potential energy is measured in joules. So that is your answer for number 1. Number 2, if a force of a 14.7 Newton is used to drag the loaded cart from the previous question, so number 1, along the inclined plane with a distance of 0.9 meters, then how much work is done on the loaded cart? So we're going back to what we've talked about earlier. Work, again, is force times distance. The force they give us is that 14.7 newtons, and the distance they give us is that 0.9 meters. Multiply those together to get 13.2, and joules is what is measured for work. Number 3, determine the kinetic energy of a 625 kilogram roller coaster that is moving 18.3 meters per second. So kinetic energy, again, is mass times velocity squared over 2. They give us the mass here and our velocity here, so we're going to plug that into the formula. The mass, again, is that 625. Your velocity is 18.3. And don't forget to square that one. Divide by 2. So again, the first thing you want to do is square this velocity. And you'll get 334.89. And then you're going to multiply your mass by that velocity squared. And you'll get 209,306.25. And the last thing you'll do is divide that number by 2. So you'll get 104,653.13 joules. And again, kinetic energy is measured in joules as well. Number 4, if the roller coaster in the above question were moving twice the speed, what would be the kinetic energy? Like we said in the notes, you can either double the speed, so 18.3, and you double that, or you know that if you double the velocity, you will get 4 times the kinetic energy. So you're going to multiply that kinetic energy by 4. So taking the previous kinetic energy from that answer and multiplying by 4, and so the new kinetic energy would be 418,612.5 joules. And again, if you turned this velocity, if you doubled that velocity to 18.3 and you doubled it and solved for it, you'd get the exact same answer. Number 5, we have a former diver, and she has a kinetic energy of 12,000 joules just before hitting the water. It has a mass of 40 kilograms. What is the speed? So I gave you this formula rearranged in the notes. The velocity will be kinetic energy times 2 over mass, and you'll take the square root at the very end. So it gives us the kinetic energy of 12,000 joules and her mass of 40. So we're going to plug that into the formula. Kinetic energy 12,000 and your mass is 40. So the first thing you're going to do is you're going to multiply this 12,000 by 2 to get 24,000. And the next step would be to divide these two numbers to get 600. And your last step is to take the square root of 600 to get 24.49 meters per second. So we're trying to find velocity. And the last question, a 900 kilogram compact car is moving 60 miles per hour at approximately, it has approximately 320,000 joules of kinetic energy. Estimate its new kinetic energy if it was moving 30 miles per hour. So we're going to be looking at how these velocities have changed. So we went from 60 to 30. So the kinetic energy is directly related to the square root of speed, meaning if you reduce the speed by 2, that means you would reduce the kinetic energy by 4. So just like up here, if you double the velocity, that means 2 squared would be 4 times the kinetic energy. Same thing, but opposite. So if you half the velocity, you will get 4 times less than the kinetic energy. So what we're going to do is take that kinetic energy and just divide it by 4. So again, half the velocity, you'll get a fourth of that kinetic energy. So now it would only have 80 joules of kinetic energy. So that is the worksheet for energy, and that is all.